Hello everyone, welcome back to my channel. Today let's go over a Leetcode medium question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This one is maximum rows covered by columns number 2397. So basically you are given this binary matrix, only zeros and ones, and another integer called numSelect. You want to select exactly this number of columns. Columns are distinct. And to make sure you cover as many rows as possible, meaning basically if all the ones in the rows are covered by whatever columns you're selecting in total, so all the columns you're selecting, then you can count that row as covered, and you want to return the maximum number of rows you can cover in any combination of numSelect columns. So there's a lot to this problem. So the way I did it was basically first get the dimensions of the columns. So that's just going to be list range from 0 to length of matrix of 0 minus 1. So if we print this, that's going to be the width. So not minus 1. Python goes up to not including this, so we don't need that. 0, 1, 2. Cool. So vertical columns. Cool. So there's only one column here, and then column 0, and then this is another example. That's fine. So another thing I'm going to do is just declare an answer and then return answer. And another thing that's really important is if a single row doesn't even have a 1, then we've already covered it. So let's just go over the matrix and say, let's call this already covered. If in this case, if 1 is not in this particular row, then we can just say this is already covered. That's already going to count towards our result if 1 is not in the row. Okay, because we're trying to cover as many ones as possible. And cool. So now for each column, we want to see what the column can cover. So we're going to want to use, well, first, let's go over each row. So let's just iterate like this through the grid. And then if the current cell is a 1, that's the only one we care about, then we can say, in that case, so the current row is going to be, so let's call this each row or something like that. And we're going to make this a default dict of type set because we're just going to say each row. So this current row, I, we're going to add I and j to it because this row, for example, row 1 covers the one in 1, 2, for example, this row. Cool. So now let's print each row. So this is going to be our skeleton because we're trying to cover as many, we're trying to basically make this empty for as many rows as we can. Okay, so, and then we're going to do same thing for each column. And then we're going to select numSelect columns. So to iterate over each of the columns, j and range length matrix of 0, and then this is the other dimension. So then we can just say, if matrix of j of I, that's how you do columns, the coordinates are flipped, is equal to 1, then we can say each column of I, because that's the column, we're going to add j and I. Okay, so let's print each column just to validate our work. Okay, so, oh, we forgot this, infinite loop. Okay, so Let's just go through this. So column 0 covers only this one at 1, 0, right? And then column 1 is 0, 1, 2, 1. So 2, 1, cool. Column 2 covers 3 ones. So 1, 2, 2, 2, and 3, 2. 1, 2, 2, 2, 3, 2. Cool. Sets are not ordered. That's great. All right. So now we're going to do the heavy lifting. So this is where we want to get all the combinations of columns. We want to select exactly this many columns. So for, let's just call this column set in combinations of columns of size num select. Let's print column set. So you can see that, let's get rid of this for now. In this case, 0, 2 is the answer. So that's going to be one of the tuples we're selecting. And then now this is really important because for all these columns, we want to see what ones we can get from these columns, which is the point of this default dict here. So let's call this all we can get is going to be, let's just call this a set. And then we need a temp because we're going to be basically erasing from each row as much as we can, but we don't want to mess up this dictionary. So let's make a default dict of type set for e in each row. TMP of e dot update each row of e. So that's just going to copy. It's like extend for lists for sets. And then now for column in column set, we can just say all we can get dot update as well, column set of, well, so for this column, we have to look here. That's what we can get. We can get each column of column because that is the set value of the column key in the dictionary of each column default dict of set, right? Cool. So now let's print all we can get. And then let's also print TMP. That's going to be important because this is basically the meat of the answer. So you can see here that we can get this, and then we can get this. So that's not going to be the answer. And then here we can get, so we can get 3, 2. That's already one row finished because we emptied this already using this. And then we can also get this. So that's 2 rows emptied. And the answer is 3 because there's one row that doesn't even have a 1 in it. Okay, that's the point of this. So now we can just say for, let's just say coordinate in all we can get. And then we have to iterate over TMP. Or actually, because we don't want to mess up this dictionary as we're iterating over it, let's go through the original each row, right? So for e in each row, because each row is going to be a copy of this TMP already. This is just a copy that's not going to mess up the original. And then we loop through the original to destroy this TMP to see how much we can erase because they're going to be the same of each other, right? That's what this is making a clone of the original. So now we can just say, for e in each row, for each key, for, let's say, c in each row of e, if coordinate, so the particular coordinate is equal to c, then we can just say TMP of e dot discard c, right? And then at the end, let's print TMP. Okay, cool. So you can see we destroyed 2 of them. So now we can just say cur is 0 for t and TMP if, let's say, not TMP of t, then we can update this, and then we just say answer is max of answer current for the current combination. Okay, so let's do this. Let's declare this here before the combinations, and then let's run this. Okay, submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching, and stay tuned for more.